This is a machine that measures the absorbance value of a specific substance. It measures the amount of photons or intensity of light absorbed after it passes through the solution being tested. You will be able to set a specific wavelength on the spectrophotometer and then measure the absorbance value of the sample solution. This machine gives quantitative data such as the absorbance value, but is also used to determine the optimal wavelength where light is absorbed best within a sample solution. Speaking of wavelength, for any stock or original solution, it is important to scan across all wavelengths using the scan program in order to find the optimal wavelength or the highest peak in the graph as seen in the bottom left for a substance, which is where the best absorbency of light can take place. Also, scanning across all wavelengths will help you find the optimal wavelength, which will also minimize the relative error of the measurement because you know that the data is as accurate as it can be for that particular sample. Using the scan program, we are sure to zero the spectrophotometer. Then we wipe the sides of the cuvette and place a stock solution within the spectrophotometer with the clear sides facing the light. When we hit start, a graph is formed in order to determine the optimal wavelength. This optimal wavelength can be found at the largest peak on the graph, which is known as lambda max. Lambda max is the wavelength at which a substance has its strongest photon absorption. In this experiment, the lambda max was at 560 nanometers. When a substance is scanned across all wavelengths, it gives you the point or peak of absorbance, allowing you to find the lambda max. Absorbance values from the spectrophotometer relate to the idea of Beer-Lambert law, which relates the absorption of light by a solution to three variables. It claims that the amount of light absorbed by a sample is directly related to the concentration of the sample and the volume of the sample of light that passes through. There is a linear relationship or directly proportional relationship between the concentration and the absorbance of the solution. As the concentration goes up, more light is absorbed and the absorbance goes up. Absorbance refers to how much light is absorbed by the sample. The first variable is the molar absorption coefficient. This is the degree to which or how well a solution absorbs light being shined on it, based on the solution's concentration at a specific wavelength. This value and its units can be found by rearranging the equation as seen on this slide. A high molar absorption coefficient indicates that the substance absorbs light well at the given wavelength. The second variable is L, which is the length of the path that light must travel through the solution, and it's measured in centimeters. This can be found by measuring the width of the cuvette. The longer the path length, the more molecules that are in the path of the beam of radiation, therefore the absorbance goes up, and absorbance is directly proportional to the path length of the sample. Third variable is the concentration of the solution, which is also known as molarity. This can be found by figuring out the moles of solvent in the solution per liters of solution. If you forget to zero the machine, it could give you an inaccurate absorbance value of the solution at hand, possibly not allowing you to see the relationship between absorbance and concentration. Therefore, it's important to zero the machine because it ensures the absorbance value measured in the sample is attributed only to the sample material and not the components of the solution within the sample or in the cuvette. For each solution using the transfer pipette, transfer sufficient but not excess solution to the cuvette. This means filling the cuvette to the line. Then grab your cuvette with the blank solution, which is water, and wipe the two sides of the cuvette with a tissue. Open the spectrophotometer and place the cuvette in the spectrophotometer with the clean sides in the beam. Close the machine before scanning the solution. Hit the zero button on the program, and once you are done, carefully remove the cuvette and close the spectrophotometer. Once you have zeroed the spectrophotometer, you are ready to get the absorbance of your sample. Grab your cuvette and clearly wipe the two sides of the cuvette. Open the spectrophotometer and place the cuvette in the machine with the clean sides in the beam, and close the machine before scanning. Hit start to record the absorbance value. Record this value in your notebook, and then once you are done, carefully remove the sample from the spectrophotometer, and then close the door. Absorbance value is 0.2425. Using the transfer pipette, transfer sufficient but not excess solution to the cuvette. This means filling your cuvette to the line. Then, grab your cuvette with the blank solution, which is water, and wipe the two sides of the cuvette with a tissue. Open the machine, place the cuvette in the machine with the clean sides in the beam, and close it before scanning. Hit the zero button on the program with the blank solution. Now, grab your cuvette with the solution and clearly wipe the two sides of the cuvette. Open the spectrophotometer, place the cuvette in the machine with the clean sides in the beam, and close the machine before scanning. Hit start to record the absorbance value. Record this value in your notebook, and then carefully remove the sample from the spectrophotometer and close the door once you are done. Absorbance value for this sample is 0.2499. One last example, using the transfer pipette, transfer sufficient solution to the cuvette, which means filling the cuvette to the line. For this technique one last time, remember to zero your spectrophotometer with your blank solution. Once you have zeroed the machine, grab your sample solution, wipe the two sides of the cuvette, open the spectrometer and place this cuvette with the clean sides facing the beam, and hit the start button to see the absorbance value. Record this value in your notebook, and once you are done, carefully remove the cuvette and place it on the side, and then close the machine. Absorbance value is 0.1195. Be sure to dispose of all solutions in the sink and clean your glassware as well as your corresponding lab area.